Hello. Uh, I hope I'm audible to everyone. So this is NPTEL PMRF live session 9, in which of the topic computer networks and internet protocol, in which we will be discussing further about routing and how that routing occurs with real world routers deployment, how the real world deployment occurs. So we will be starting more in a minute or two. Let other people join as well, and then we can start. Okay. So, as we know about the IP routers, which are the layer 3 switches and which helps to make a connectivity from one device to another in between the network. And there are multiple routers present with the device to device connectivity. Okay. So, this is the broader layout of the router, that is the outer part, and these are the inner configurations of a router. And what is the life of the router? So, if in case of the router, what we do currently now is that we find the path for which the router needs to forward the data and the amount of data that it needs to transmit. and then it forwards to the next router, and similarly next router finds the path and forward it to the another router. It repeats this process until it is powered off or the data has been reached from one source to the destination. So there are two basic operations which are conducted in case of router. That is, one is the to construct the routing table. That means the router should have the information about the right routing table. That what will be the source address, destination address, source port, and destination port, etc. And what is the data that needs to be transmitted. So this is constructing the routing table is the for one of the operation of a router, and this is known as the control plane, which constructs the routing table. And then there is another operation in which we do a routing match and forward the packet to the dedicated interface. For example, if we have detected, if there is a packet arriving at the router, then the router checks it from the its routing table whether there is a match to a certain source address and finds its destination address, and then forwards the packet to a dedicated interface. So that routing match is done over the hardware in a router, which is known as T-CAM hardware that we have studied, which we have studied in the previous lecture. This is a hardware which stores the routing table and then does a routing matching and forwards the packet to a dedicated interface. So this processing or operation is known as the data part of the data plane. Okay. So what was the evolution of the router architecture? The first generation was introduced in 1980s with a standard computer which contains the information. Then we follow it by the second generation, where it delegates to the interfaces, that is early 90s. Then there is third generation in late 1990s, where they introduced a distributed architecture for the router architecture. That means one router has different architecture, another router has different architecture. So that is a very distributed architecture. Then the fourth generation in early 2000s, that was distributed over multiple racks. That means there are multiple racks and each rack is contained with a certain amount of routers and they have a common router architecture. So finally, we have the fifth generation, that is today. It's the software defined routing. So we will further discuss in this lecture what is software defined routing and what is the motivation behind introducing a software defined routing. Okay. So yeah. So when we wait, I'm not. I think I'm when we when we when we Yeah, sorry, I was just checking the voice. So there is a proper connection. Okay. Then we introduce the basic architectural components of a router. So what are the different components of the router? So let me first check whether yes. So one part is the processor, which is the memory or the CPU, which stores the information that of the router. Then there is interconnection network through which there are multiple interface cards connected through certain ports and source and destination IPs. Okay, these are the basic architectural components of a router. So processor is responsible for the control functions, that is the routing. These are the route processors. They construct the routing table based on the routing algorithm. Yeah. So I was just mentioning in the current lecture that the router architecture consists of a processor and the interconnection network. And the processor is responsible for the control functions, that is the route processors. It constructs the routing table based on the routing algorithm, whatever routing algorithm is chosen, whether it is a path vector algorithm or link state algorithm or direct vector algorithm, distance vector algorithm, etc. So forwarding is done at the interface card. That is, it matches the route needs to be very fast. So the specialized hardware which is used for this, that we have discussed in the previous lecture, is TCAM, which is ternary content addressable memory. So this is the router hardware. This is the control plane, which constructs the routing table based on the routing algorithm. And then we have the data plane, which does the forwarding part. So then we have the router internals. This is how it is done. So this is the router processor which has the routing engine, and it forms the control plane which controls all the routing information and defines the routing table based on the routing algorithm. Then we have the packet processor which does the matching with the particular source and destination IPs, and it is connected with the interconnect fabric with different interface processors which does the matching part, and then it forwards the packet through this packet processor to the desired destination address. So this right part is the control plane, and this left part is the data plane which matches the data, and packet processor forwards the data further. So there are slotted chassis, that is the physical infrastructure of the routers, which are present inside the routers. So large routers are built as slotted chassis, which is the interface cards are inserted in these slots, and root processor is also inserted in a slot. It simplifies the repair and upgrades the processor as well. Okay, so the functional components of the router is as stated. So one is the table update. So the broader motivation, let me tell you about this software based routing or centralized routing. That is because of the case that for with the previous years of invention, we are more dependent upon the distributed architecture of routing. However, consider a case when there are more than 1000 or 2000 routers that needs to be configured in a same space or in a same network. So at that time, if individual vendor have their different architectures and provide their decentralized architecture in a distributed manner, so every router needs to understand the routing mechanism and the centralized distributed architecture of all the other routers. So that is a very tedious task when there are more number of routers. So for that purpose, it is very difficult to handle such amount of data. So even management of the data is not possible, and even the scalability of data is not possible. So for that reason, we introduce the centralized version of controlling the router, in which we have this functional components, one divided into control plane and another one is the data plane. So the control plane develops or maintains the table and updates the table based on the routing algorithms. And it is the mind or the processor of the router. And then we have the data plane, which does the per packet processing, that it matches with the routing table with the its header, that is the source IP and the destination IP and the port and the source port and the destination port. And after the route lookup, it forwards the packet to the destined location. So note that what is a control plane in a router? Router is a special purpose computer. It is implemented as a software, that is router OS, which is a control plane that supports the basic, yeah, just that supports the basic computing functionalities to run a router along with the router functionalities. So routing protocols are implemented in the router. For example, there is Cisco IOS, which gives us a router with a predefined architecture. So this routing functions are as follows. It calculates the route, it maintains the routing table, it helps in execution of the routing protocol. So on commercial routers, routing functions are handled by a single general purpose processor called the route processor. So then we have the data plane of a router, which implements forwarding functionalities. That is, it makes a route lookup and forward the packet at the destination interface. So its functionality is similar to a L2 switch, that is, you switch fabric, the mapping from input port to the output ports to forward the packet from one interface to another. It maintains interface buffer to implement, store, and forward the functionality. So in IP forwarding, per packet processing of the IP packets takes place, and IP forwarding is distributed, that is handled by the individual interface controllers, not in a centralized manner. And the special hardware devices which are used for IP forwarding is known as TCAM. So this is the per packet processing or the basic architectural components where we have the output scheduling ports and there are the input scheduling ports, and in between is the switch fabric. So here we have the routing table which makes the routing decision, and then we have the routing table with us in which the data plane checks for the source and the destination IP, and then it interconnects the input port with that particular output port through a switch fabric. So there is this forwarding information base. This is the interface which maintains a forwarding information base, a mapping from input interface to the output interface. So a replica of a routing table used at the interfaces for making the forwarding decision. So whatever is the routing table available at the control plane, a mapping or a replica of that routing table is stored at the individual router for making a interface between input interface and the output interface. So this is how the FIB works and the processing works. So there is an incoming packet at the input interface. Firstly, it will go for a lookup of FIB in the in this router. So if there is a FIB present, that is FIB hit, then it forwards the packet while matching it with the particular router interface and forwarding it to the output interface. And if there is a FIB miss, that means there is no routing information available at the router or the data plane. Then it does a FIB miss, and then it does a route lookup for the control plane. And when it finds out an appropriate route, then it fills up the FIB lookup. Okay, so what is the difference between RIB and FIB? So RIB is the routing information base, that is the routing table implemented in software and is maintained at the control plane. And forwarding information base is the copy of the required routes maintained in the interface of TCAM hardware at the router end. So RIB is dynamic and maintains entire routing information. So whenever there is a change based on the routing protocol, so RIB is dynamically updating itself, whereas FIB is updated whenever it is required. So whenever there is a FIB miss, it does a route lookup and then use that information at the FIB. So take this example. This is the RIB, which has the uh, yeah, this is the RIB which has these four lines of information with it. And this RIB contains the source IP and the destination IP and the intermediate router, and to which next router it wants to transfer the information. So this routing table is implemented at the control plane. And then we have the F5B at the Ethernet 0, which has the three lines of information for passing through Ethernet 1, 3, and 4. Similarly, FIB at Ethernet 1 needs the information only about Ethernet 0 and Ethernet 3. So it has only two lines of this information. So depending upon the requirement of a particular packet, it updates the FIB and those information are stored in FIB. So what is TCAM? That is ternary content addressable memory. It is a specialized high speed memory which searches its entire content in a single clock cycle. So ternary means it stores and query data using three different inputs, that is 0, 1, and don't care or wildcard bit. So searching is based on the pattern matching. Example 110 and don't care. And match content that starts with 110 start rest bits are don't care bits. So RAM is assessed via the address where the data is stored, and CAM can be addressed by performing a query for the content itself. So it retrieves the address where the data is founded, which is opposite to the RAM. And also, CAM is very much faster than the RAM processor. Okay, so this is the basic TCAM architecture that is being used at the router end. Okay, so I'll just restart the session in 5 minutes. I have something important to do. So just halting for a break of 5 minutes. Yeah, hello. Sorry for the delay. Yeah, so this is the TCAM architecture. Here we have the prefix masks, and this is the team CAM format that is derived from the prefix mask. As you can see here, this is 101/3. That is the initial three bits are 101 and then don't care. Next we have 111/3, that is 111 and then don't care. And similar in this way, we have the TCAM architecture for the matching. Okay, I think everybody is aware of this architecture. So here are certain IP and route commands which are used for IP address show, IP link show, that shows the IP address, and IP link show which shows the link information, and IP minus S address show which shows the statistics of that particular address, and then route minus N which shows the IP routes, and IP route list which shows the IP route routes possible for that router, and then it adds another, if you want to add another IP to that IP route with the new route of Ethernet 0. And this is how we add it to the IP route. So you can try these command at your end and see how that works. And I think the live demo has been already given at the NPTEL lecture. So there is this trace route command which trace the route of a destination. That is one from our machine. If it does do a trace route for 172.16.2.30, and it traces the route of the destination. So, okay, we'll study further about the software defining networking. But before that, let us discuss the prior assignment of the last week. Yeah, so this is the question. I would like if you answer them. So when you connect your personal computer on any device or host to the internet, how does it know or assign its own IP address and the gateway IP address to use the sending packets to remote host without any manual configuration? Yes, so TCAM is a hardware for that router that is present inside the router, which does the matching of the through the particular route packet for the particular packet, the destination address, and it finds the route for that particular packet. Yeah, so answer is DHCP. That is right. That is Dynamic Host Configuration Protocol assigns IP address to the devices that connect to the network. So second question is, why do we consider dividing an IP address into network address and host address? Yeah, so the correct answer is C, to avoid overhead of storing all possible host IP address in each route. It by using network address, routers can forward packets like the system. That means with the layer wise addressing, and by looking the relevant network address only instead of the entire host address, it can follow the particular network, and the routers do not need to store all possible host IP addresses. Then the question is, which of the following statements are correct? In question number one, you're asking why isn't it B? So, for connecting your personal computer to the internet, uh, yeah, so if it form its own routing table, it can connect through multiple devices. It can connect through the next possible route to that particular destination address. But if you want to send packet to the remote host without any manual configuration, then DHCP is only responsible because it assigns IP address to the devices that connect to that particular network in between that network. So for that purpose, routing table is not necessary. Answer which of the following is correct? Yes, it is true. It is true. Fourth is correct. However, second one is also correct. So, explanation is that this much. Oh, sorry. The answer is C. That means only four is correct. So here it says that distance vector routing and link state routing protocols are example of intra-domain routing. So can you tell me the example of inter-domain routing? Yeah, right. It's a path vector routing algorithm, that is BGP. Okay. So next question is, for the following network, what will be the routing table for C if we use the link state routing? So please try to solve this question. I am giving you some time. Just check it out. What will be the routing table for C? Yeah, that is right. A and E by via B. What about others? Please take the time and solve it. Okay, so the answer, correct one is this A. So if you want to go to A, next stop is through B. If you want to go to B, next stop from B. If you want to go to D, that means directly. There is no intermediate. And if I want to go to E, the next stop for E is B. So this is the correct link state routing table. As you can see here, for A it is B, for B it is B, for D it is E. So this is wrong. And similarly, for A it is B, B is B. Then for D it is E, that is again wrong. And even for E it is through A, that is wrong. Firstly through B and then through A. So this is how this is the uh, best routing table, possible routing table. Okay. So next question is, in BGP protocol, the update and notification messages are used for. So correct answer is C, that is exchanging reliability information and notify an error is the functionality of update and notification in BGP. So what is true about BGP routing protocol? So the correct answer is D, that is BGP relies on IGP for packet forwarding between IGP peers. So BGP communication packet types are. Why not B? So for B, it is a type of link state routing protocol. So how is that a correct thing? We know that BGP is a type of path vector routing protocol. So how it is a link state routing protocol is true. I hope it is clear. So next question is, with BGP communication packets are of which types? Yeah, so correct option is B, that is open, update, notification, and keep alive. These are the communication packet types of BGP. So next question is OSPF, that is open shortest path first, is a distance vector routing protocol, link state routing protocol, path vector, or hybrid routing protocol. Yeah, so the correct answer is link state routing protocol. So which types of routing protocol use Bellman-Ford algorithm to calculate best path for the forwarding IP packets? So link state routing protocol, distance vector, hybrid, or path vector routing. So correct answer is B, that is distance vector routing protocol. It uses Bellman-Ford algorithm to calculate the best path for forwarding packets. They exchange routing information between routers by periodically sending their entire routing table. So consider a network for yeah, any questions in this? So next question is, consider a network with three routers A, B, and C. The routing table for route A has the following entries. If router A receives an IP packet with the destination address of this 192.168.1.10, what will be the next hop for this packet? Yeah, for full cursor, I mean, in the distance vector, it firstly does the routing based on the shortest distance possible. So Bellman-Ford algorithm, it tries to find out those shortest routes between a source and the destination. So that is used for distance vector routing protocol. So Ford Fulkerson also is responsible, but Ford Fulkerson finds the path, but it does not compute the shortest path. So that is done by Bellman Ford algorithm. Yeah, so the correct answer for this question is B. Since the destination address of IP packet is 192.168.1.0/24 subnet, router A will forward the packet to the next hop, router B, because it matches with this, the destination address matches with the given next hop B address. Okay. So let us discuss further about what are the software defined networks. You are unable to understand this question, just wait. Yeah, so there were three routers A, B, and C, and this was the routing table for A. Okay, so it was given that for this destination, the next hop will be B. For this destination, the next hop is D, and for this destination, the next hop is C. So when we are given a destination address of 192.168/1.10, so what will be the next hop? So in this case, since the destination address is uh, with this subnet, if we AND it with the subnet, it gives us the similar network ID. Okay, so this destination is about the particular subnet, that is the network mask. So when we do the subnetting with of this with this /24, then it will result in this destination IP, that is 192.168.1.0. That means it is the best possible match, and then for that purpose, the next hop will be B to reach this destination. However, if you do a subnet mask with /28, it will not give the same resultant. It will give the other value as the resultant. That means, I guess, the last two digits will be 0, 1. So that is not the correct subnet. And similar is the case with this one, which will not lead you to the correct subnet. So that is what the reason is. I hope you understood about that. Yeah, what are the question? Question number 4. Yeah, so question number 4, in this link state routing method, we want to form a routing table for C. So we first check for given node B. So for B, there are multiple routes, that is C to B, then C to E, A and B, and other as follows. However, if we want to reach to B, 1 is the best possible or the shortest route taken. So accordingly, it updates. Similar with the case of A, it is through B is the best possible distance. So to reach B, it is next hop is B from C. To reach A, next hop from C will be B. To reach D, next hop will be D. And to reach E, the next hop will be B. Okay, so this is demonstrated for routing table of C. Yeah, so let us further discuss about the further details covered in this week. So this is we'll talk about software defined networking. Software defined networking is a network framework which involves in separating a network's control functions from its data forwarding functions. That is centralizing its intelligence and abstracting its underlying architecture from application and services. So as we know, there are two planes. One is the control plane, which is the head or the brain, which takes all the decision. It's basically an instructor and which stores the routing algorithm and forms the routing table. And then the data plane is the module which carries out the task given by the control plane, that is forwarding of packets. So traditionally, the network devices were proprietary. That means all the vendors decide the software or the hardware data plane and the control plane. There was no standardization. So if there is possible that some routers arriving from Cisco, some routers from Juniper, etc. So all the routers from different vendors have their different software and hardware architectures. So there is no standardization and the architecture is highly distributed, and for a large number of routers, that is a very problematic thing. So, what does separating control and data plane means? And what if they were separate? That means vendor only provide the hardware, that is data plane, and we decide the control plane by writing a custom logic, that is the software. So, if there are more than 1,000 routers, so all the system will be centralized if we have their individual data plane, which are mentioned by the vendors, and all the routing decisions or the routing algorithm are formed by the custom logic written on the control plane from an centralized individual. So vendors only provide the hardware, that is the data plane, and we decide the control plane by writing the custom logic. So initially, this is the control plane in which we have the routing table, etc. And this is the data plane of different in where we have the output ports. And these are asking for the updates from the routing tables from the control plane. So what are the advantages is that features are no longer limited to what the vendors provide. So we need additional features as well. So it is better if we have a global software to decide about the features which will be present in the particular set of routers. Then there is community development and longer life of products. So how does this SDN works? So compared to traditional networks, a software-defined network has two types of devices. We know controllers and the switches. The switches in SDN are blind, that is, they have no inbuilt feature and they need to be infrastructured by the controller. So the switches works as a data plane and then we have the controller which works as the control plane. So the controller is the brain of the network. That means all policies, routing logic are placed inside the controller and it teaches the switches what to do with an unknown packet. So this is the brain that is the controller. So when a packet wants to go from H1 to H3, this is a network and this is switch 1, S1. So wants to go from H1 to H3, it has no information what to do and how to transfer it. So then it asks forward the request from H1 to S1 to rectify how it wants to reach to H3. So then the S1 further asks the controller, that is C0. So there is no rule if as there is initially no rule in S1 to how to reach from H1 to H3 at the beginning. So that will be leading to FIB miss at S1. So then S1 asks the controller generates the rule based on the software program, that is the routing logic. And then this controller sent the rule after the request from S1 back to the S1. And after that, till that time the packet is buffered at S1. Okay, I hope everyone is clear till here. The packet is still buffered as it is a table miss, and when the information is received at S1, then it does with a table hit and the rule is installed at the FIB of S1 with the rule 1, and the buffered packet is forwarded based on that particular rule. So all the future packets from H1 to H3 will follow the same rule, which is stated here. So this is the broader SDN architecture in which the last layer is the programmable switches with the input and the output ports. Then we have, this is called the infrastructure layer. Then we have the control layer, which is the brain of the architecture, where all the software and the computing and the controlling power is residing. And then we have at the top is the application layers, which have the application running on a physical or virtual host. So the application communicating with the control layer, this is known as northbound APIs, and then the control layer communicating with the programmable switches or the infrastructure layer is known as the southbound API. So this is the traditional network versus now the software developed network. Here there is a distributed control plane in which we have multiple control planes, and they were distributed throughout. Different APIs wants to access different routers, and each router has a different control plane and data plane. And then comes the SDN architecture, which has the centralized control plane, which is required for all the routers collectively. I hope everybody is clear till here. Yes, so here are some closed innovation in the network community, that we have three layers. One is the packet forwarding hardware, then the network operating system or the control plane, and then is the application. So, so there is a SDN based approach to to open the innovation. So we have this packet forwarding at the lowest level, then the collective network operating system, and then the applications. So this is the SDN architecture as we mentioned, with the southbound interface and the northbound interface. So the northbound communicates between the application layer and the control layer, and the southbound communicates between the control layer and the infrastructure layer. So how do we interface between the control and the data planes? So here we have the network operating system and an open interface to the hardware, which can be seen or used by all the hardwares. So then these are the packet forwarding hardwares and extensible operating system to convert programs to rules. So then we have the open API for the app development. So what is the open flow? This is the way how we communicate between the control plane and the data plane. So it is protocol for controlling the forwarding behavior of Ethernet switches in a SDN. It was initially released by Clean Slate program at Stanford, specially now maintained by Open Networking Forum. So SDN messaging interface, this is the SDN matching interface, and we can use different types of languages, that is ONOS, Mistral, Ryu, or depending upon the requirement of what type of operating system you want to build. So how does OpenFlow works? This we have the control path, that is the software, and the data path, which is the hardware and is implemented in the TCAM. So then we have the OpenFlow controller, which OpenFlow messaging API with using SSL or TCP. Then we have the control path and the OpenFlow, and then the data path. So what does the OpenFlow client does? So it is a software layer which stores all the information, and then the hardware layer, which is connected through various Ethernet with multiple IP addresses. So it can take the map the IP address from the destination to the source. So this is the power of OpenFlow, that anyone can write their set of operating systems. So, for example, Bob wants to write his own set of network rules for forwarding his packet. So, he maintains a Bob's forwarding app, and with the help of this app, all the networking takes place, network rules. So, every router follows the same forwarding rules. Similarly, if Alice wants to forward through another set of rules, she maintains her own forwarding app, and which is again used by all the routers for communication between themselves. So that means individual person can set up the individual set of rules with that particular network. So there are four categories in open flow table, that is rule, action, statistics, and priority. So rule, what they does is to have the exact rule in the open flow, that is switch port, MAC of source site, source address, then MAC of destination node, then the Ethernet type, then IP of the source and IP of the destination, then IP of the TOC and TCP port or TCP destination port and TCP source port. So all this information is stored as a rule for a routing table or open flow table. Then comes the action, which allows to forward packets to zero or more ports. It encapsulates and forward the packets. Then it modifies the fields and drop, or it can also drop the packet. Then statistics is the packet and byte counters which are implemented. And priority is the rule priority, that which packet is given more priority for, say, or which rule is given more priority if there are similar rules for, say, a single packet. So there are certain examples of the open flow tables. So one of the example is of switching, in which we want to switch the port. So we have the MAC of the destination address and the action. That means the incoming packet should move to Ethernet 2 for the switching of which we need to have a firewall over a certain for a certain destination port. Here the destination port is mentioned and the action is to drop that packet. Similarly, we have the forwarding, flow switching, source LAN switching. So once TCP connection is made, open flow hello message is exchanged between the controller and the switch. It negotiate open flow version and agree on the highest version supported. So controller sends OpenFlow feature request message and get the data path ID of the particular switch. It determines what features with switch supports. So based on the application program, OpenFlow messages for switch configurations are sent. So to check aliveness, echo request and echo reply flow messages are sent from either controller or the switch. To group flow entries, groups are configured by Yeah. Groups are by the controller through group messages that can be stored in the group tables. To get statistic details from the open flow messages like flow stats, port stats, queue stats, group stats, table stats, etc., it can be sent from the controller. Asynchronous flow open flow messages like flow rule removal from a switch, configuration apply fail error from switch, port up down status from switch, etc., can be sent from switch to update the controller. So this is how a packet processing is done, which we have the router and the switching utility and the offload client, open flow client. So thank you. This was the summary. I mean, I'm not going into details. Just for a recap, I was mentioning those things. And now we can have a discussion on the similar type of assignment that you can see in this upcoming week, which you are given. Sorry. So the control plane of a router is responsible for these are the options. Mritunji, you have asked a question, so we need to have separate device for to control. I didn't understand what do you mean by that. Role of both. What is the role of both? Yeah, till the meantime you answer these questions, the control plane of a router is responsible for. Yes, so the router only has the capability to perform an operation about the control plane. We need not to have a separate device about that, because that is just a software uh, that is needed. So for that purpose, only that software is written on the router itself, or this is a centralized software system that is used by the router. And so the correct answer for question number one is that control plane is responsible for building the routing table. That is C. It is connected with building the routing table of router using various routing algorithms. Yeah, it is responsible for controlling the hardware resources, but hardware resource, it cannot handle the hardware resources. However, it handles which path the hardware will decide to go, decide for the router to go. So that is done by the routing table. So it does not, the resources for the hardware are entirely different terminology and different things required. It is not the similar meaning as we are saying here for building the routing table and then forwarding that packet. So next question is, which of the following is not true regarding forward information base, FIB? So the correct answer is B, that is, it is responsible for merging the data plane and the control plane together. That is not true because FIB mirrors the routing information base, that is fine. And routing decisions are taken from FIB, not RIB, that is also fine. And it is stored in TCAM hardware is also fine. But it is not responsible for merging the data plane and the controller plane altogether. Which of the following is not a function of a router? The answer is D, that packet retransmission is a function of the transport layer, specifically the TCP protocol. Routers do not perform packet retransmission, but rather forward packets to the destination based on the routing table and other factors. What is the main advantage of software-defined networking over traditional networking? Yes, the correct answer is C, that is easier management and configuration. So SDN allows the centralized management and configuration of network devices, making it easier to deploy and manage complex networks. So what component of SDN is responsible for communicating with the controller? Yes, the correct answer is B, that is the control plane. So that is responsible for communicating with the controller. The control plane is responsible. Okay. What is the role of open flow protocol in SDN? It is A, to enable communication between the control plane and the data plane. What is the role of data plane in SDN? Yeah, so the correct answer is A, to process network traffic and forward packets. Question number 8. Which of the following is not the use case of SDN? Just think about this question. Yeah, so the correct answer is D, that is voice over IP, because it is a type of application that runs over network, but it is not specifically a use case of SDN, because rest other threes are a part of the network, that is cloud computing, Internet of Things, virtual private networks, but VoIP is an application. What is the role of southbound interface in SDN? Yeah, so the role of southbound interface is to enable the communication between the control plane and the data plane. The queries, but ma'am, since STN can be used to configure network priority or for VoIP, it is a use case of VoIP too. No, SDN is directly is not a use case of VoIP too. So SDN is a kind of software which has been written for your routing and the routing protocols, the route management. So that is implemented over a network. So then indirectly that can be a use case of many types of things, but VoIP is an application, and directly this SDN is not a use case of a particular application. Yeah, that is true. But you first understand like SDN is a like we can say that in a network, all the seven layers on architecture are useful for anything. Okay, for how to make the routing possible. But if we want to make an end-to-end connection, then we rely on the reliable connection. Then we rely on the TCP layer. So, however, or the transport layer. But we cannot say that indirectly we are relying on the network layer or not. So that is a kind of example I'm trying to give you. So the last layer is, what is the role of northbound interface in SDN? Yeah, so similarly, the role of northbound is to enable communication between controller and applications. So I think everybody is clear till now. So we will discuss about the other things in the next lecture. So thank you. If you have any query, you can ask. Otherwise, we will end the session. Yeah, what question, Akshat, you want to ask? You can raise your hand or turn off your mic. Yeah, I've allowed your mic permissions, so you can ask the questions directly. Mm.
Ma'am, good evening, ma'am.
Yes. Good evening.
Ma'am, excuse me, last classes I was unable to attend.
Okay.
I want to ask, are you going through this course for a first time or you are like what?
I mean, why is that needed for?
Ma'am, because I want to know what a student faces problem in this course.
What a student?
Faces the faces problems in the course.
Yeah, so I mean, I have taken this course for the first time as NPTEL lecture, but
Yeah, ma'am.
I mean, problems, I mean, I'm not aware of because I haven't taken it very frequently. So this time, whatever I'm trying to see, like there are certain understandings regarding the practical implementation and how that can be practically used. So that
Yeah,
is
ma'am.
a big problem for many of the students.
And practical use.
Yeah, I mean how the network implementation is done practically, or like as I mentioned in theoretical way, or you are being taught in a theoretical manner, but how this
Yeah,
course enables in practical manner, or how that network commands or some IP commands are used. So that kind
yeah, ma'am.
of use case is difficult to interpret only in theoretical languages.
Yeah, ma'am. Okay, ma'am. Thank you, ma'am.
Okay, fine. Okay, so we can end today's lecture. Yeah, you can refer to the courses which are being taught online as well. So there are I courses from IITs which talks about networks, and you can access those courses over even NPTEL, and without NPTEL also publicly available courses are there. So you can search over the internet and then you can access those courses. Like if you can search from the department of computer science, and then you can see a list of professors and what are the courses that are being taught by the professors, And then you can refer to the page. They have their slides, they have the information about the course, and you can access to that course. Yeah, there is a lot of research projects going on which covers networks. For example, I will give you example of video streaming, which has been uh, talked upon as a network problem, like how the video is streaming over the internet and what is the buffer, bitrate, etc. So one of the fellow researchers with us is working over that area, broader area. So yeah, this is the possible scope that you can explore as well. Okay, so let me end the lecture. I mean, I'm stopping the recording. Thank you all for attending the session.